Then the final speaker is David Connolly, Associate Professor at the Aalborg University in Copenhagen, Denmark. He's Project Coordinator, Heat Roadmap Europe. David is a graduate of the University of Limerick and has many publications to his name in the area of sustainable planning, green energy and future in Europe.
Good morning, everyone. It's great to be back home for a change. Nice to see a few more familiar faces than the usual Anderson, Rasmus and Jesper lying around in the audience. As the introduction said, I come from Copenhagen these days, where I work as an associate professor in energy planning. And I suppose just to set the scene, and I think Fergal and Matthew have really given me a great platform to go with, I don't worry so much about the short term. I'm very much focused on the long term. So what I'm going to talk very much about today at the beginning here is where we want to end up, because a lot of what I deal with as well is not just around bioenergy, but it's about how the whole energy system is meant to change over the next 30 or 40 years as we move to a deep decarbonisation. And what we find is that when you look at the short term, a lot of the challenges can seem very difficult to prioritise. But when you look at the very long term, about where we actually want to end up, then actually a lot of the options become very clear and very simple to make. Because when you actually look at where we want to end up, a lot of the options simply fall away and a lot of the restrictions become very evident. So I'll start by talking about the long term, but my big challenge for today, and I found it really difficult to prepare for this presentation because I have just so much to say in so little time that I feel you might be peeling me off this podium by the time I get to 11:15. So I'm going to start to save, in case that happens, with my conclusions. And the 4 key points that I'm going to try and make today are, number 1, that in the long term, bioenergy is absolutely guaranteed a no-regret solution. And the reason for that is we will not have enough of it. And I'll give you some evidence to back that up in a minute. The second thing is, though, what might be a regret is not if we'll have enough of it, but it's how we'll use it. And I'm going to give you some examples to highlight the concerns about how we may use it in the wrong way. And in the short term, although I'm going to focus on, let's say, the ideal way to use bioenergy in the long term, what I'm suggesting here today is by no means suggesting that we should stop what we're doing, because developing bioenergy is not something that will start in January 2034 and be ready in January 2035. It's something that will take decades to develop the supply chain, develop the markets, develop the technologies. So for sure, even though it might not be ideal what we do today, we still need to do what we're doing. And the final thing I want to propose is that while developing bioenergy itself, we also need to develop the infrastructure we need to use bioenergy in the best way. And the most suitable, or one of the best pieces of infrastructure to start with, that's already proven in other parts of Europe today, is district heating. So what I'll try and do is give you some evidence to back up some of these points in as best I can in the next 15 minutes or so. And the first thing I want to talk about is how bioenergy is for sure a no-regret option. I'm going to skip maybe 1 or 2 of these just to save a bit of time, but my key point with showing some of these pictures is that we're entering an era of a new normal. The Danish government about 5 years ago made an official target that they would be fossil fuel free in 2050, and since that date there's been numerous other countries following suit. So we're entering a phase where people are openly committing to 100% renewable energy systems. Not deep decarbonisation, not reducing fossil fuels, but eliminating them. And even the Paris Agreement set that agenda very firmly in place, not just on a, let's say, national scale, but on a global scale. And if this is where we want to end up, then this is what we should be aiming for. We should not be aiming to fix a problem in 2020. We should be aiming for this new normal. And when we look at today's energy system, this is a very, very high-level schematic of today's energy system in Ireland. It is very poorly equipped to deal with that challenge. The reason is because you can see in today's energy system, all of our demands, whether it's transport, electricity, or heating, are all connected back primarily to some form of fossil fuel, which is one big problem. And number 2, they're all very isolated from each other. In Ireland, we traditionally have thought of these sectors as separate entities, which unfortunately, as a system, has made them relatively inefficient. And in the future, if our aim is to eliminate all of these fossil fuels, it's not just the fuel we're losing, it's the stored energy, which of course is a huge problem when the thing we're starting to rely on in the electricity sector is wind energy. And without going into the details, because I know many of the people in the room know all of this, that means when people look around and say, we need some form of energy storage. Well, bioenergy is that wonderful form of energy storage, because bioenergy is what can replace these fossil fuels. And the challenge is, though, it's not figuring out how bioenergy is useful, but it's figuring out how much of it do we have to replace these fossil fuels. Because when you look at the numbers, if we start stacking up what we need in this new normal of 100% renewable energy systems or deep decarbonisation, it becomes very clear that not only we don't have enough, nobody has enough. You cannot import your way out of this problem. So I just took some estimates as to what Ireland's bioenergy resource is expected to be in the future. I know Matt gave some updates in his presentation, but on the left here is the primary energy supply in Ireland last year, or 2015, versus our expected bioenergy resource in 2050. Where is all the rest going to come from if we want to achieve what all the politicians are telling us we want to achieve? So we need to be using as much bioenergy as we possibly can get our hands on, and we need to use it in the most sustainable way. I've also included a slide looking at various estimates for the bioenergy resource in Europe, and the main point with this slide is don't worry so much about the details, it just presents the exact same story. Europe doesn't have enough bioenergy to replace all its fossil fuels either, and you can find the same picture when you look at the global scale. So what I want to point out here is, if we look at this change where we're eliminating fossil fuels, if we're going to rely on, let's say, wind, wave, solar and tidal in the electricity sector, they're probably going to be limited by their intermittency, whereas bioenergy is going to be somehow limited by getting our hands on as much sustainable bioenergy as possible. So in this context, you're doing an essential job, and do as much of it as you can possibly do, because there will be no scenario I've ever seen where we have overproduced bioenergy, as long as it is in a sustainable way, of course. So this is hopefully just give you some evidence to prove that bioenergy is an essential part of the future. But what I also want to put into your minds is that this means, because it's going to be limited, we also have to use it in the best way possible. And I'm going to give you two examples, some which you may have heard of before and some not, of how, when we look this very long distance into the future, of how we can make the most of it. And the first is something I call cascading, or you could call it efficiency, or whatever you want to call it. But basically, this is, if you imagine we're living in 2050 and we have 3 terawatt hours of bioenergy, one for the transport, one for power, and one for heating. What happens is, right now, because these sectors are so separated from each other, we're not maximizing the efficiency of this very valuable resource. If we connect these sectors together, therefore start using the synergies between electricity and heating, for example, we can start taking the waste products, say, for example, from biomass power stations and use it to provide our heat rather than just simply throw it away. And what happens that when you do this is the overall system gets a huge boost in the system efficiency. So what people often say to me is, well, boilers are actually pretty efficient. They have 80, 90+% efficiency. But from a system perspective, they're actually very inefficient. But in order to make the most of these synergies, we have to have this relevant infrastructure in place. So, for example, to do this, you would need a district heating system in our cities in order to take advantage of this excess heat. And just to highlight this problem, it's not just bioenergy we will be using inefficiently in this process. It's all other types of heat that we would throw away at the same time. So it might be biomass that we're burning in our power plants. It could also be waste we're burning in waste incinerators. It would be heat being discarded from industries. And it would be, let's say, these new biorefinery plants that might have some excess heat available from them, as well as other renewable resources. And this is why I just want to put the point out there that it's not just about developing a fuel, it's about developing infrastructure that also is suitable for that fuel also. Another technology I won't go into too much detail about, but you might have heard of it, is what I would call boosting bioenergy. This is something called power to fuels, power to gas, electrofuels, synthetic fuels, call it what you want. But the idea here is that we need to get as much value out of 1 unit of bioenergy as we possibly can. And the way that they do that is by combining bioenergy with electricity, such as wind and solar power, in order to get more fuel for our bioenergy, you could say. And you can look at these slides afterwards maybe to see how the whole thing functions. But basically it's taken the carbon out of bioenergy, combining it with electricity in order to produce some liquid or gaseous fuels. And the reason that this makes a lot of sense from a bioenergy point of view is, if you look at the energy flows, bioenergy, for 1 terawatt hour of bioenergy in, I'm getting 1.2 terawatt hours of fuel out. Whereas if you look at, say, for example, bioethanol, typically you get 1 unit of bioenergy in, you get 0.4 units of bioenergy out. So here you're getting 3 times the value for your 1 unit of bioenergy, which is essential in the context that I'm talking about, which is a world where bioenergy is a very scarce and limited resource. So this is, let's say, something that hasn't been developed, whereas district heating is something you could say that is a well-proven technology. And I left in some literature there for you to look at. So these are the type of technologies that we need to maximize in the future if we actually imagine we can achieve what all the politicians are telling us we need to achieve. I carried out a study about 2 years ago. It's open source, scientific study. You can read it yourself if you have the time or the interest. And this is where I went as far as I thought Ireland could possibly go when it came to utilising things like district heating and boosting its bioenergy resource. It is a very, very optimistic scenario, with us all getting in line and all making the most of the synergies. This is a very rough overview of what the energy system looks like in my study. You can see it's much more interconnected, a lot more synergies being utilised, trying to get as much value out of our bioenergy as we possibly could. I'm not going to dwell on the numbers too much. I just want to make the point that even in my study, where I went gung-ho all the way, even then, the amount of bioenergy I needed, if Ireland was to ever achieve a 100% renewable energy system, was 50 gigajoules per person, whereas Europe is estimating that they have about 25 gigajoules per person of a resource. This is just to give you a sense of how valuable this resource is going to be in the future. Or else we need to just admit to ourselves we are not getting off fossil fuels, because that is the other alternative, of course. So that's the long-term picture. And of course, I just want to wrap up with just talking about what this means in the short term. Because the long-term picture is scarce resource, extremely valuable to the energy system, and we need to make the most of it. In the short term, we may be doing things that don't fit with this long-term picture, but of course that doesn't mean we don't do anything. We need to develop the fuel supply chain in order to use it in the future. And I'm sure there's many people in this room that know how to do that in the coming years much better than I do. It's just to say that I don't want to leave the signal at the end of this talk that for a second I suggest we stop what we're doing. But I also think we need a lot more awareness about the infrastructure side of things, about how we use it. And when I look at these long-term options, I don't think we should start trying to develop power-to-fuels or synthetic fuels in the near term. I think we should look at district heating as an ideal way to start utilising our fuels in a more efficient manner, because this has been proven, whereas power-to-fuels is something that's being developed. And just to give you a sense of how proven it is, this is a map of Europe and the different renewable energy shares in the heating sector. And if you look at these countries, Denmark, Sweden, Finland, Latvia, Lithuania, Estonia, Austria, all of these ones that have shares of 30, 40, 50, 60% have enormous district heating networks. Because district heating is an enabling technology that lets you get large penetrations of renewable heat into your buildings. I'm leaving out the Norwegians because they're a bit odd in this whole picture. And just to give you some facts about this is a picture, I saw Matt put up a picture of how our renewable heat penetration in Ireland has developed since 1990 to now. And as he said, you can barely see the change. It's something like 2 to 2.5%. In contrast, look how Denmark's renewable heating share has developed with district heating as an enabling technology. In 1990, bioenergy was almost non-existent as a renewable energy technology in the heating sector. Today, over 30% of district heating is supplied with bioenergy, and district heating supplies over 2/3 of the households. So you have bioenergy directly feeding over 20% of the buildings with heat in less than 25 years, let's say. And then, of course, there also is the bioenergy that goes into the waste incinerators. So this is just to give you some facts behind the theory that this is something that works as an enabling technology. I set up a survey on a website just to see what the status was with district energy in Ireland. I know ORB are trying to do something similar at the moment, but I think whatever I'm sure it's not a big industry, district heating in Ireland these days, but I think it would be very valuable if Airbia or anyone else can start to create some capacity in this space so we can realistically prepare ourselves, as Fergal said, not just for 2020, but for a 100-year plan in the future. So that's my 2 cents. I hope you got some inspiration from hopefully what's down the road, and look forward to some questions afterwards.